Welcome to this video on the proxy design pattern in C#. It's a software design pattern that makes a habit of standing in for other objects. So what exactly is it that the proxy design pattern does? It basically acts as a surrogate or a stand-in for another underlying object. So you can think of it as a go-between. It controls access to objects in order to support either slow or resource-intensive processes or to add extra functionality. Basically, it can also act as a gatekeeper. Now, there are several types of proxies. One is a cache. So in this instance, there might be a resource that is difficult to create or time or resource intensive to create. The cache proxy can act as a go-between that can store the resource once it's been created the first time, and then subsequent calls to the resource won't require to be recreated. It will simply be passed back. So in other words, it caches an object that has been created. We also get a protection proxy. Now, a protection proxy adds a layer of security. So when an object acts as a protection proxy, it can decide whether it would allow external objects access to the object for which it's acting as a proxy. A remote proxy serves sort of as the local representative for a remote object. So the remote object might be on another PC or on another machine that sits on the other end of the world. The idea behind this proxy is that the local device that tries to consume the resource would have no idea that the actual resource is situated on a remote device. We also have smart proxies. Smart proxies add functionality. So if there's extra functionality that you want to add to say for instance, you're making a call to a specific object, what the proxy can do is it can sit invisibly in between the call and the object that is being called and add extra functionality without the client actually knowing that the original object isn't the thing providing all the functionality. Lastly, we get a virtual proxy. Now, a virtual proxy allows us to simplify the interface that an object provides. So in other words, the actual object might have 10 methods available, where the virtual proxy sits between the actual object and the client making the call to the object, but it only makes available a subset or a combination of the methods that are actually available on the real object. So let's have a look at the class diagram for the proxy software design pattern. The class diagram consists of three entities, the first of which is the subject base. The subject base will be used to tie together a real subject and a proxy, because the idea of the proxy design pattern is that the proxy needs to be of the same type as the object for which it's acting as a proxy. And to accomplish this, they need a shared common base. Now in this case, the subject base provides that shared common base. For this example, the subject base has a single method called perform action. The real subject would then inherit from subject base, which would be an abstract class, or we can create subject base as an interface, in which case real subject would implement this interface. Because it either inherits from the abstract base class or implements the interface, it needs to have the perform action method. Now the real subject, very importantly, it can exist and it can function without a proxy. So it doesn't need to have the proxy to actually work. It will work perfectly well without the creation of a proxy. But we can create a proxy for that specific real subject. So when we create the proxy, it needs to save a reference to a real subject object. Because it's going to be acting as a proxy, and because it's going to be a subject base, firstly, because it's a subject base, it needs to implement the method perform action. But because it only acts as a proxy, it doesn't necessarily have its own functionality. What it does do at a very base least limit is that it should call some other action on the real subject. Now in this case, the simplest form of the proxy would be if the perform action is called in the proxy, it simply calls the perform action method of the real subject which it is hiding basically. Now you can imagine we've mentioned that you get various kinds of proxies. So in other words, if it were a cache proxy, there would probably be an extra field over here to store the cached object in whichever form it might be. For protection proxy, we might have extra functionality and perform action that says only if a certain username and password are provided, or only if the logged in user is of a certain level, do we allow perform action to be called. So this is a very basic version, just to give you insights into the concept. But one of the most important things to remember is that the real subject can exist and can function completely without a proxy being created. The proxy is basically just an extra. So we can access the real subject either directly or via the proxy. And then very importantly, both the proxy and the real subject must implement the same abstract base class or interface. Let's have a look at a real world example. So in the real world, we have legal entities. Now, a legal entity would be something like a person or a company that are able to make legal decisions. Now, a legal entity must be able to deal with legal issues. So in this case, say for instance, we have a company. The company has a name, and the company is able to deal with its own legal issues. But what happens in many instances? Companies or private persons might hire a third party to deal with its legal issues for it. In such a case, we would probably call that person a lawyer. So the lawyer would be appointed to act as a go-between for any legal issues that the company would have to deal with. So the lawyer, with regards to legal issues, could be considered a proxy for the company. So whenever someone wants to perform any kind of legal issue with regards to the company, the lawyer would deal with the legal issue and then pass it through to the company. As we saw with the basic version of the pattern, we have to remember that the company is still a legal entity on its own. So regardless of whether or not a lawyer has been appointed, the company is still free to deal with its own legal issues. But whenever it chooses to do so, it may also make use of the lawyer to deal with its legal issues.
All code created for this video has been written using Microsoft Visual Studio. Microsoft Visual Studio is a one-stop IDE that allows you to write better code faster. Its IntelliSense provides for AI assistant development on Windows and Mac platforms, and it allows for a multi-platform development process.
So let's have a look at what this example would look like implemented in C#. Firstly, let's take a look at legal entity. Legal entity, according to the class diagram, has a single method called deal with legal issue. For this example, it was declared as a void, so there will be nothing returned. And the class in which it has been created, the legal entity class, has been declared abstract. Now, as mentioned before, this could also work by creating an interface instead of an abstract class. So, because we are not providing any base class implementation of this method, the method is also implemented as an abstract. This forces all derived classes to provide their own implementation of this method. So the next class is that of company. Now, firstly and most importantly, company has to implement, if it's an interface, implement the interface legal entity, or in our case, because it's a class, it should inherit from the class legal entity. From our class diagram, company also has a name. I chose to implement the name as a property, but specifically, the get method is public and the set method is private, which means it's able to be retrieved by an external entity such as the client application, but the name may only be set within this class itself. To do that, I created the constructor so that it receives the name of the company, and then we simply assign the name of the company. Now lastly, we still have to meet the requirements of the class which we are inheriting from, legal entity, which means we have to have a method called deal with legal issue. And take note, the use of the override keyword to ensure that we are actually providing our own version of the method as specified in the base class. Now all we're doing in this method, because it's simply a quick example, is we're simply outputting saying that litigation is in progress. So as soon as we start dealing with a legal issue, litigation is in progress. The last class we need to take a look at is that of the lawyer. So again, lawyer, as prescribed by the details of the proxy pattern, or the basics of the proxy pattern, also needs to be of type legal entity, since the actual real subject and the proxy, which in this case is the lawyer, need to share the same base class. In other words, they need to be able to be used as the same basic type. So to that end, because the proxy is going to act as a go-between for another object, we have to save a reference to that other object. Now in this case, the lawyer is acting as a proxy for a company. So we need to store in a private field a company object. The company object is passed to the lawyer in the constructor, although this could have been done differently as well. We could have used a property which would allow the company to be set externally, but that's more of an implementation thing. It doesn't have too much to do with the pattern itself. And then lastly, because it is a legal entity, we need to provide an implementation of the method deal with legal issue. So all we did in here is we're outputting a message that says, I'm a lawyer and I'm representing a specific company with the name taken from the company itself. And then after that is done, it simply calls the company's deal with legal issue method. Now recall, as we said as we went through the example, depending on the type of proxy that you are creating, there might be other functionality in here. So in other words, we might only call this method if certain criteria, such as a username and password, have been met. Also, a more complex example, we could have had multiple methods over here, so names of specific legal issues, and then over here the methods that we had would do different things depending on the kind of legal issue. So it can actually modify methods or add functionality depending on the kind of proxy that you want to implement. Now the last thing we need to take a look at is our main program, i.e. putting it all together. So in this case, we created two different companies, Company A and Company B, and then a lawyer. So what we have to realize first, these two companies exist without a lawyer being appointed. I'm not going to say created, because the lawyer most probably exists as well. But in this context, a lawyer would be appointed to work with a company. So let's just keep the terminology within the scenario. Then, after we've created the companies, we can assign a lawyer to work with a specific company. But what we have to take note of is the following. The first time we do legal action, both companies work without a lawyer. So Company A is able to deal with the legal issue and Company B is able to deal with the legal issue. Even though Company B does have a lawyer appointed, they don't necessarily have to make use of the lawyer. Okay. So technically this should be down here, because in the next step I say Company B appoints a lawyer after losing the first legal battle. So we should actually be putting this here. The reason I didn't place it down here is I simply wanted to demonstrate that we can call Company B even though it's already been assigned a lawyer. But regardless, let's leave it as this. Let's have our initialization at the top and the calls down here. So what it says over here, Company B appoints a lawyer after losing the first legal battle. So now for the next round of litigation, Company A is still dealing with its own legal issues, but Company B no longer deals with the legal issues directly. It is using a lawyer as a go-between to work on its legal issues. So let's run this and see what happens when litigation starts. So let's check out the output. So initially we had two companies starting legal actions, both without a lawyer. So litigation is in progress, litigation is in progress. Company B then appoints a lawyer after they lose the first legal battle. So again, the two companies start legal action, this time the one without a lawyer and the other with the lawyer acting as a proxy. So the first company basically just says litigation is in progress, but the second company has someone that sits in the middle and handles the affairs of the company. So in this case it says a lawyer steps in and says, I'm representing my client, Company B, and then litigation is in progress. So in other words, from the perspective of the client application, using the company object and the lawyer object, when the application is run, it basically does things transparently. Everything is handled equally. And the reason we are able to do this is because the lawyer and the company both have a common base class. So we can use them interchangeably. And that brings about the power of the proxy pattern to invisibly add extra features or limit features without the external client actually knowing that anything has changed beyond the results that it's receiving. I really hope you enjoyed this video on the proxy software design pattern in C#. If you found this video useful or entertaining, please click on that like button. If you want to be notified of more videos like this, please click on the subscribe button and hit the notify icon. Happy coding!